car of mass 1 times 10 to the 3 kilograms traveling west at 20 meters per second crashes into the rear of a stationary bus of mass 5 times 10 to the 3 kilograms. The vehicles locked together on impact. Show calculations to test whether or not the collision is inelastic. So this actually takes a little bit of working out. There's a few things we need to do here. So, for it to be inelastic, or let's test for elastic. That would mean our EK initial is equal to our EK final. Okay, if it is elastic. So we need to know both of those quantities. So EK initial is 1/2 mv squared. We'll call it VI initial. It's equal to 1/2 mvf.
What about squared?
Oh yeah. Thought I'd forgotten something. All right, now we should change these m's as well because our m's are going to be different. Oh, yeah, I'll put I and F because that's just the convention I've used so far. But yeah, you could use 1 and 2. Okay, so the problem here is M initial we can work out. We're given it. You know, the car's moving, the bus isn't, so the car is the only thing that has kinetic energy initially. So MI is just going to be the mass of the car. VI will be the speed of the car before the collision. MF, well, our vehicles are locking together, so the final mass is going to be the mass of the car plus the mass of the bus. But VF, our final velocity, is difficult because we don't know after they collide how fast they're traveling. So, in a question like this, we need to be aware of the fact that momentum is always conserved. Energy, not always, in terms of collisions. Momentum is always conserved. So, using that knowledge, we can use our momentum to calculate our final velocity. So let's do that. So, our momentum initial is going to be equal to our momentum final. So our momentum initial, mv, so our car's mass is 1,000 multiplied by 20, which is going to be equal to our momentum final, which is the mass of the car plus the mass of the bus multiplied by v. Okay, so we get 20,000 is equal to 6,000 v, and so v will be equal to 3.33. So after our vehicles have locked together, they've locked together and they're travelling with a speed of 3.33. Now if we have a look, does this pass our common sense test? We've got a car hitting a stationary bus. The car was travelling at 20 meters per second. The bus is heavier, so we'd expect it to lose a lot of speed, but still keep going. Okay, so common sense test passes. All right, so now we know the final velocity of everything after the collision, so we can work out our equation up here. So, our initial kinetic energy is going to be 1/2 times 1,000, because again, the car is the only thing with kinetic energy in the beginning, multiplied by 20 squared. And that is going to be equal to, what's that, 200,000. 200,000 joules, because we're talking about energy. So our initial energy, our initial kinetic energy is 200,000 joules. For this to be an elastic collision, our final energy must also be equal to 200,000 joules. So let's see if it is. I'll move this down here. So 1/2 mv squared, so 1/2 multiplied by, so the mass of both of them after the collision, they've come together. So the mass of the overall object is now 6,000. So it's the 5,000 plus the 1,000, multiplied by 3.33 squared. If all goes well, that should be at least less than what we're expecting. Cool. So it's about 33,000 joules. To a couple of significant figures. Okay, so we can see here we have started with 200,000 joules. Our Objects have collided. We've finished with 33,000 joules of kinetic energy. So obviously we've lost a lot of energy to sound and heat, but, you know, the momentum is conserved. Okay? So in this case, our collision is inelastic. This is how you need to prove it. Anytime you see these words on an exam, inelastic or elastic, first work out your momentum to get your final velocity, then check to see if the kinetic energy is constant. Okay? Anytime you see inelastic or elastic, the first thing you should be doing is calculating momentum before and after. Okay? Any questions? All right, have a go at the next one.